Okay, so this is a question for our Chapter 16, dosages measured in units. So this question has three different parts that we're going to solve for. We're going to figure out how many units we are going to administer, how many milliliters we would administer for the bolus, and then how much or how many milliliters per hour we would then run the infusion pump. So in this question we have calculating the units of heparin for the bolus dose, which is here, and then here we're going to figure out the milliliters by using this, and then we're going to find the milliliters per hour for the infusion pump, and that's what this is. So in our question we have begin a heparin drip per the facility's protocol. That patient's weight is 96 kilograms. So that's the first bit of information I'm going to write down. Then our protocol says to bolus 80 units per kilogram. So that's what we're going to be solving for here. How many units? Then we're going to add to that how many milliliters for our bolus. And then we're going to solve for our milliliters per hour on down here. But I'm going to go ahead and write here for our infusion, we need 18 units per kilogram per hour. That's what this is. And then our heparin concentration is 25,000 units in 250, or this 100 units per milliliter. So let's do our units first here. All we need to do for units, I'm going to solve this one here, is to take our units and times them by our kilograms. So here we have 80 times 96, which gives us 7,680 units for our bolus. And then I want to solve for how many milliliters. So in that case, with dimensional analysis, we're going to put milliliters on top. So I'm going to put that here. And in our have quantity, down here, we have 100 units per milliliter. So I'm going to put 1 milliliter is equivalent to 100 units. And we want to give 7,680 units per dose. So then our units would cancel out. So we would do 7680 divided by 100, and that gives us 76.8 milliliters that we would give for our bolus. So we would put that here. And then we're going to solve for our infusion rate. So we're going to have 18 units per kilogram. So with that one here, we're going to plug in our kilograms for our 96 kilogram patient. So I'm going to do 18 units times 96. And that gives us 1728 units per hour, because we got our kilograms out of there. So now I'm going to go down here and solve for milliliters per hour, and with dimensional analysis we start out with milliliters on top. So in this one we're going to use this same quantity, so we'll put 1 milliliter over 100 units, and then this is what we're going to then plug in, because units here have to be units here, and that's what this is, 1728 per hour. So with that being that part of our question being completed, our units will cancel out and then we're going to be left with milliliters per hour. So in that case we're just going to divide 1728 by 100, and that gives us 17.28 milliliters per hour. So rounding that one, we would just leave that in the whole number, so that would leave us 17 milliliters per hour. And that gives us our third part to our question. So again, we have 3 parts. We want to figure out how many units, then how many milliliters for the bolus, and then how many milliliters per hour.